Welcome to the Zoomtown experiment. Progress is being made, and actually it's pretty darn good. However, along the way, a very mysterious problem started to reveal itself. I'll talk a little bit more about that near the end of the video, and that'd be the subject for yet another video after this. But for today, let's just focus on the changes I've made and the results that they're showing me. I have a video of this, and what I've done is I've filmed 10 test drives with each of my two different working Zoomies. And I'll get that playing up over here in the corner, and so you can observe that and see how it's all playing out. Now, I would like to let you know that the speed at which you're seeing it will not be at 100% speed. I'll either speed it up or slow it down to fit within the time I'm busy talking here. So I'll be down in the corner and we can let that video run up there. As with the test in the last video, the start point of the Zoomie is intentionally being random, within about 1 inch or 25 millimeters from being on the true zero starting point. This is to introduce a variable issue. I don't like to just run tests that everything is perfect in them, and that's one variable that I see will introduce problems that I need to deal with, or hopefully they'll reveal themselves in the testing. Watching the video, you can see that the Zoomie travels along the road, parking at each location along the way. This test run includes the following maneuvers: sweep turn, which is a large radius turn; a cruise, which is moving along a straight line, doing line following, etc. Pivot turn is a tight turn which pivots on one wheel, and I use that to go in and out of driveways and to make sharp turns from one roadway to another roadway. You will also see that it's parking, where we pull into the driveway and stop before crashing into the barrier. That's always a thing that I'm trying to avoid. And then finally, we'll also be unparking the car, where we back the car or the Zoomie out of the driveway to get lined up to make the pivot turn to go on the next road section. What makes this test a really big success is that I used two different Zoomies, as mentioned earlier, the yellow cap one and the red cap one. And on the video you're watching there, the yellow car will make its 10 passes, and then the red one will make its 10 passes. But most importantly, it made it through the full test of 10 runs successfully, each car. That is huge. I've never been able to get that much reliability out of the system. Now, to qualify that, I'm not running off of the scheduler sending in directions. Everything is running from within the Pico, which is why you see the umbilical cord still connected to the Zoomie. With that great achievement, I'm very encouraged that this whole project can keep moving forward, and I won't have to scratch everything and start completely over. Now, here are some of the changes being implemented and tested within what you're watching right now. First off, you'll notice that the background, the road surfaces, all the 1-inch marker tapes are gone. All of the other marker tapes are gone, with the exception of those for line following. You will see a singular marker tape, and what I mean by marker tape is a 1/4 inch wide, about 6 millimeters, piece of tape that's black in color that crosses the lines that we use for line following. All those are gone. Looks a lot nicer. You will also notice that all the magnets are gone. I am no longer using Hall effect sensors in this process of navigating. The important thing here is that I'm still using the encoders, and I'm still using the interrupt method. I had talked earlier about wanting to go to the PIO routine that I wrote to do the counting, but in initial testing, the PIO routine and the interrupt routine were providing the exact same count numbers, give or take 1 count. So it didn't see advantageous to introduce a problem with the PIO routine instead of the interrupts. It also, the PIO routine, created a very long delay in when I fetch out of the FIFO buffer from the state machine. That takes an insanely long period of time to get that data. And that does not work well with our system that we're trying to put together for position control. I did mention that I still have tape markers that are crossways to the line following, and those are at the exact stop points where I need to make a decision, so to speak. Either I'm going to turn or I'm going to stop to cross a T intersection or a four-way intersection, etc. And that's the only time we should see a piece of tape, once per destination or intersection. So that really, again, tidies everything up nicely. With those markers, they serve a very crucial new purpose. We've always fought the encoder feedback for providing very precise positional data. Very precise by, from my perspective, about a 64th of an inch or a half a millimeter. That's been my goal all along, and I could never achieve that with encoders alone. So I'm using the encoder right now to get me into proximity of that marker tape. Then, as I see that marker tape with the front photoreflective sensors, the TCRT 5000s, then I stop the moment I transition off of that piece of tape. And that has been working very reliably throughout this entire experiment. Another really important change that I've done, and this was something I wanted to do earlier but just never did. I never took the time to do it. During a pivot turn, either the pair of front photoreflective sensors or the pair that are on the back of the Zoomy will assuredly have to cross the white guideline that we use for line following. So whether I'm going forward or reverse, I would use whichever pair of photoreflective sensors. So instead of using the encoder of the moving wheel to go X number of counts, instead what I do is again use the encoder to get me into approximately the position, and then I let the Zoomy go while monitoring the photoreflective sensors so that as it rotates to its final position, I'm centering up that pair of photoreflective sensors on the line following line. With that in place, then it should be a matter of just moving in the direction for the next heading using a cruise maneuver. That was very tricky to implement. Primarily, the rear ones were worse than the front. The front ones were using analog feedback from those sensors. So I can make sense of whether we're on or off of the line a little more simply, we'll say. I can look for both analog values to be below a certain threshold and to see a rise and fall before. The rear two TCRT 5000 photoreflective sensors are operating digital. They are either on or off. Now that would seem to be a little easier, but in truth it's proven to be a little more difficult. But a little bit more fancy hand waving over the keyboard, and I think I've got it working pretty good. I don't know if it'll be my final solution, but it certainly is a great step forward. What that allows us to do is to make that turn and be pretty confident I can go off in that direction and be lined up with the line to follow. And that has been, so far, a good addition and a good change to our process. I know, I'm really excited about all these changes and the improvements and how they're revealing themselves in the test runs that you see up over in the video. But don't be fooled. As this project has proven over and over and over and over again, there are always challenges that arise as I get closer. One of the things that I discovered is that the distance sensor is not very reliable, and that really isn't helping us in positioning, but I will be using it, or plan to use it, when I park the Zoomy or back out of the driveway. I could use that sensor to see where I am relative to the barrier, where the end of the driveway is. And I started coding all that in there, but was having variability that I couldn't understand. I thought, okay, well, let's look at this a little closer. I took a Zoomy, put it in the driveway, not having it move anywhere, I turned on the sensor and monitored the position that it's reading. The variability was 0.3 inches, 5/16 if you're into the fractional world, or in the metric world, about 7.62 millimeters. Just sitting there, the numbers are floating around in that range. Far from my 1/64 of an inch or a half a millimeter. So I won't say that that's a total failure to our new concept, because truthfully, the whole point of that sensor, the distance sensor, is for sensing to see if something is in the path that the Zoomy is moving, like another Zoomy on the road surface. But being that it was capable of doing what I wanted to do with the driveway situation, it just turns out I can't use that. So I got to go back to my simple rules and forget extra sensors and stay on that course. So that was, I won't say a failure or a mystery or anything like that. I'll say it was a disappointment. Using the black tapes as the endpoints is concealing a mysterious problem, though, in the encoder feedback system that I've never really understood. Again, I keep mentioning it, we've had this problem all along. Well, I can mask it with this new concept most of the time, but it still creates problems. And how I discovered the latest problem, after I wrapped up the filming for that last test, the one that you're watching over here, I pulled out the turning in and out of the driveways out of that sequence, and then I was going to continue up over around the sweep turn at the end, and then start working my way to go around these blocks, like city blocks. And suddenly things went very wrong with the new system. Totally puzzled me. So I kept digging and digging, and I still am digging and digging, but I found something very mysterious in there that might help us understand what's been going all along, and I never questioned it. Well, I questioned the problems we were encountering, but perhaps not the cause of them. But that's the subject for another video. But I will say this testing that I'm doing with what I got here really kind of revealed what was seemingly innocuous, as just a simple thing I was doing that could have been creating all of these problems. So that's where we're at with that. And by the way, that change in positional error that seemed random oftentimes could have been 2 or 3 inches. So we're talking 50 to 75 millimeters. And of course, there's no way the system is even going to work under them conditions. So with that, let's wrap up this video. If you find these videos interesting or entertaining, I sure would appreciate it if you could subscribe or give me a thumbs up, or even better yet, drop a comment below to tell me what you're liking or not liking, or maybe what you'd like me to try, or if you just got a question. It really helps the channel grow, and I really have to drive up views and subscribers, etc., so that I can keep funding these videos. So I greatly would appreciate it if you could do that. If not, that's fine too. Hang around, watch the videos, and that's wonderful as well. Thanks again for watching, and I look forward to seeing you in the next video.